Hey everyone, in this video I'm going to give you an overview of what Newton's first law is. So we all sort of know the quick and dirty version of Newton's first law, but carefully I'm going to state it as an object in motion will remain in motion unless acted on by a net external force. The converse is obviously true as well. An object that is not in motion will remain not in motion unless acted on by a net external force. So Newton's first law gives us the very first insight into why objects move. If an object is in motion, it's in motion because either it was always in motion, we don't know anything about it, but it was always in motion, or it was acted on by a net external force to put it into motion. So why am I being so careful about net external force? Well, it turns out that just a single force is not enough to tell you whether an object's motion will change or not. You need to know about the net external force. And net here means sum of all of the forces. So add up all the external forces. If it's zero, the object will remain in motion. If it's not zero, then the object's motion will change. And so let me try to give you a specific example of that. So here's a hockey puck sliding across a slippery surface, ice, at a velocity v. So the first instinct we have is, okay, if the friction is perfect, if there's really no friction, then the hockey puck will slide forever and ever and ever, and that's fine. That seems to be a statement of what Newton's first law is. But if we just think a little bit, we have to say, okay, well, are there any interactions between the hockey puck and anything? And if the hockey puck has mass, certainly hockey pucks are pretty massive, maybe half a kilo or something, then there is an interaction between the hockey puck and the Earth. I'm going to call that Fg, that's the force of gravity. So there are external forces acting on this hockey puck, specifically that from the Earth on the hockey puck. So it would seem that Newton's first law would say, oh, no, okay, its motion will change. But then we have to think, okay, if that was the only force, just without knowing anything further, our intuition would say, if that's the only force, then the hockey puck's going to be pulled downwards by gravity. That seems not to be happening for a hockey puck on ice. And that's because there's this additional force. It's called the normal force. We're going to learn more about it, but for right now, I think it's pretty convincing it has to be there because the hockey puck is not moving downwards because of the gravitational force. It's being held in place while it's sliding. So this net external force means that in order to determine if an object's motion is changing, we have to add up the normal force and the gravitational force. In this case, that plus that equals zero. So there is zero net external force, and this hockey puck will continue to slide forever and ever and ever, according to Newton's first law. So that's a simple example, but the takeaway from Newton's first law is exactly the statement that I have here, but just remember that it's net external force. It doesn't mean that it has no forces acting on it. It means that if you add up all the forces and the net force is zero, then the object will continue to stay in motion. Also, objects will not start moving unless there is a net external force on them.